There is a fireproof building material that is carbon negative, increases in strength over time, and has consistently proven to cut energy bills by over 50%. Yet in 1970, the United States government made it a federal crime to even touch the stuff. The building material is called hempcrete, and it is perhaps one of the most remarkable building materials we have in our arsenal today. So, what makes it so revolutionary? Why did powerful industries try to bury it? And how can it help you right now to save thousands on your energy bills? Let's find out. The modern revival of hempcrete began in 1986, when an artisan named Charles Rossetti was tasked with restoring the Maison de la Tourque, a landmark building in the French commune of Nogent-sur-Seine. Rossetti faced a challenging dilemma that had defeated restoration experts for generations. Traditional masonry was slowly destroying the building. As the ancient timber frame flexed and swelled with changes in temperature and humidity, the rigid masonry and fill of stone and brick refused to move with it. This rigidity caused the masonry to crack, trapping moisture against the oak beams and causing them to rot, threatening to destroy the entire structure. Rossetti's solution to this problem was both brilliant and unorthodox. He opted to abandon the rigid approach of traditional concrete and stone entirely, experimenting instead with a mixture developed from the woody inner core of the hemp stalk, known as the hurd. By combining this hurd with a lime binder and water, he created a lightweight infill that was flexible and breathable, moving in perfect harmony with the wood rather than resisting it. The solution worked. The ancient beams dried out, the structure stabilized, and the building was saved. But while Rossetti is credited with the modern revival, the history of the techniques he was using was far older. Hempcrete, or lime-hemp mixtures, originated over 1,500 years earlier, with evidence of it being used in the 6th century on the Merovingian Bridge in France. While in India, archaeological investigations at the Ellora Caves, a UNESCO World Heritage Site, have found hemp fibers worked into the earthen plasters of Cave 12 as early as the 6th century AD. The ancient builders understood that the fibrous nature of the hemp provided structural reinforcement to prevent cracking, while the natural insect-repellent properties of the plant protected sacred murals through every monsoon season for over a millennium. But, to appreciate why hempcrete is such a technical anomaly, we need to follow its life cycle from the moment it is packed into a wall to the decades inside our walls. The process begins with hemp hurd, which for all intents and purposes is a waste product. It's the woody material that's been left behind after the long textile fibers have been stripped away for rope or clothing. Under a microscope, this hurd reveals a compressed latticework of tiny chambers and tunnels, a cellular structure with an exceptional capacity for trapping air. The hurd is then mixed with a lime-based binder and water. As the water evaporates, the mixture begins to firm up, and the brilliance of hempcrete begins to manifest thanks to a process called the carbonation cycle. Unlike Portland cement, which hardens through a rapid hydraulic reaction, the lime binder in hempcrete begins pulling carbon dioxide directly out of the surrounding air. Through a slow chemical reaction, the lime reacts with atmospheric carbon dioxide to return to its original state as calcium carbonate, which is essentially the same mineral that makes up natural limestone rock. Essentially, the wall is slowly turning to stone around every fragment of hemp, encasing the interior in a mineral matrix that is inherently non-combustible, while becoming measurably denser with every passing year. This petrification process can run continuously for up to 12 years after installation, meaning the wall you build today will actually be harder and more fire-resistant a decade from now than it was on the day you finished it. It is a material that simultaneously removes greenhouse gas from the atmosphere while becoming more durable, a feat that no conventional insulation on the market can replicate. And because the wall is vapor permeable and hygroscopic, it allows moisture to pass through rather than trapping it, which naturally regulates indoor humidity to between 40 and 60%. This is the exact range that health researchers identify as optimal for human occupants. And while conventional American construction relies on expensive mechanical dehumidification to reach this goal, Hempcrete achieves it through the wall itself. But one of the most common mistakes people make when evaluating Hempcrete is comparing it to fiberglass or spray foam based on R value alone. Hempcrete provides a steady-state R value of approximately 2.0 to 2.5 per inch, which is admittedly lower than some synthetic alternatives. However, Hempcrete works through two different mechanisms in tandem. While the air trapped in the herd's cellular structure provides the insulation, the stone-like properties of the wall act as a thermal mass. It absorbs heat during the warmest part of the day and releases it slowly as temperatures drop. A conventional lightweight wall, on the other hand, stops insulating the moment its interior temperature equalizes with the outside. But a Hempcrete wall keeps working for hours after the heater has been turned off. This is the same principle that makes traditional adobe construction effective. But Hempcrete adds superior insulative properties to the mix. And there's another huge benefit to Hempcrete that we've not even mentioned yet. The lime binder maintains a pH of roughly 12 throughout the entire life of the structure. This extreme alkalinity is lethal to mold, which requires a much more acidic environment to colonize a surface. In laboratory conditions, researchers have exposed hemp mortar to sustained high humidity for a full year and found absolutely no mold growth. The same chemistry makes the wall a fortress against pests. The silica content of the hemp herd deters rodents, and testing at the University of Hawaii against Formosan subterranean termites found that mineralized hempcrete caused significantly higher termite mortality than traditional Douglas fir controls. In regions with aggressive termite populations, such as Australia, entomologists have found that termites have virtually no effect on the material. The encouraging lab tests are one thing, but it is a whole other level of proof when you see the impact hempcrete has on real-world construction. In 2012, the British retail giant Marks & Spencer opened a 195,000-square-foot store in Cheshire, England, using prefabricated hempcrete wall panels. The post-occupancy monitoring revealed that the store used 42% less energy than a comparable conventional building, and it even required 60% less heating fuel than its own engineers had predicted. During the winter, the building lost less than 2 degrees Fahrenheit of heat overnight, whereas a standard retail environment would have lost closer to 16 degrees Fahrenheit. In the United States, the first permitted hempcrete house was completed in Asheville, North Carolina, in 2010. Known as the Push House, this 3,400-square-foot residence utilized 12 in hempcrete walls and reported monthly cooling costs of under $100, which was a 60% reduction compared to similar homes in the area. The homeowner even reported that her insurance premium was cut significantly after the carrier reviewed the fire performance data of the wall system. And that fire performance was recently validated in a landmark U.S. test conducted in July of 2024. A 12-in spray-applied hempcrete wall was subjected to 1,200 dF for 60 minutes under structural load at a facility in Pennsylvania. The wall not only passed the fire exposure, but also survived a subsequent high-pressure hose stream test. During the entire hour of direct fire exposure, sensors on the exterior face of the wall registered almost no temperature increase. While the fireside face was being blasted by conditions that would have vaporized fiberglass or turned spray foam into toxic fumes, the outside surface remained at near ambient temperature. On standard tests for flame spread and smoke development, hempcrete scored a 0 on both measures, a result previously achieved only by mineral wool. But the benefits of using hempcrete in our home go far beyond just personal gain. Hemp is a high-efficiency carbon sink that can grow to 15 ft in a single 100-day season, absorbing approximately 9.8 tons of carbon dioxide per acre. Because the construction industry utilizes the hurd, which is a byproduct that would otherwise be wasted or burned, that carbon is effectively locked into the building's fabric for the life of the structure. Peer-reviewed life cycle assessments consistently find that hempcrete walls achieve a carbon-negative footprint, meaning they sequester more carbon than was emitted during their production. In a typical residential project, this results in the permanent removal of several tons of carbon dioxide from the atmosphere. And with such a compelling record of safety and efficiency, it is baffling that modern construction is only now implementing this as a mainstream material. While Rossetti's restoration of the Maison de la Tour put a spotlight on hempcrete within the country, just 200 hempcrete homes in France were built between 2000 and 2021. And while adoption in Europe is slowly increasing, it's still stubbornly slow for a material that offers undeniable benefits over conventional means. But the situation across the Atlantic is even more restrictive. For nearly 80 years, bureaucracy and industry lobbying made utilizing hemp nearly impossible in the United States. The Marijuana Tax Act of 1937 didn't ban hemp outright, but it imposed restrictive tax stamps that were nearly impossible to obtain. The American hemp industry, which had once been one of the most widely cultivated crops in the country, collapsed almost overnight. Many believe this was the result of powerful industry lobbying. William Randolph Hearst, who held massive investments in the timber industry and paper mills, utilized his media empire to launch a campaign against the plant, deliberately misleading public opinion by linking industrial hemp with the psychoactive effects of marijuana. This suppression was codified into a total ban by 1970 under the Controlled Substances Act. For the next 48 years, it was a federal crime for American architects or engineers to even hold hemp hurd in their hands. While French and British builders were perfecting national standards and testing the material in commercial skyscrapers, the United States was in a legal blackout. By the time the law finally changed in 2018, the American construction had accumulated decades of inertia built around fiberglass bats, spray foam, and the supply chains and training programs that supported them. A material with no domestic testing record and no position in the building codes had no clear pathway to adoption. Thankfully, that legal barrier finally broke in 2024. The International Code Council approved the inclusion of hempcrete into the International Residential Code. So, for those looking for a natural, superior insulation, hempcrete is a brilliant option, although there are some important considerations to keep in mind. The first and most important thing to understand is that despite the name, hempcrete is not a load-bearing material. You cannot use it to build a structural foundation or a roof that supports its own weight. It works as the infill and insulation within a structural frame, typically made of timber, and if you are looking to swap out traditional insulation for hempcrete, it requires rethinking the wall assembly to ensure it remains vapor-open. You should avoid materials like OSB or plywood that can trap moisture, and instead use wood fiber boards or direct lime plaster substrates. Of course, making your own hempcrete is a perfectly viable option. But for most people, the most accessible entry point is prefabricated hempcrete blocks. Companies like Hemp and Block in Colorado now manufacture these domestically, and they can be ordered online without a specialist contractor. These blocks arrive fully cured, which eliminates the 6 to 12-week drying period required for traditional cast-in-place hempcrete. There are even notched retrofit blocks sized to fit directly within standard 2-4 or 2-6 stud framing, meaning you can upgrade the insulation in an existing wall without demolishing the entire structure. And if you are looking at a larger project, there are now prefabricated wall panels available from companies like Homeland Hempcrete in North Dakota. These panels can reduce wall construction time by an estimated 75%, allowing a typical house shell to be assembled in just a few days. For those who want the full performance of a monolithic wall, companies like Americhanvre in Pennsylvania hold the rights to advanced spray-applied systems. While Hempcrete construction currently carries a premium of roughly 10 to 20% over conventional stick-and-bat construction, that gap is closing as regional supply chains mature. Furthermore, the operational energy savings up to 50% on heating and cooling tend to pay back that initial cost over the medium term. And under current federal tax guidelines, homeowners can even claim a 30% tax credit for qualified insulation costs. One of the most inspiring examples of this new economy is the Lower Sioux Indian Community's Seed to Sovereignty program in Minnesota. They have built their own $2.3 million processing facility and are growing over 120 acres of hemp on reservation land to build hundreds of hempcrete homes for their community. They estimate that these homes will save 70% on energy costs compared to conventional housing while providing much healthier living environments for their families. The story of Hempcrete is a reminder that a technology doesn't have to be new to be revolutionary. It is a 1,500-year-old material that pulls carbon from the sky, turns itself into stone, and protects the health of the people who live within its walls. It was sidelined and forgotten for 80 years, not because it stopped working, but because it was a threat to the profits of more powerful industries. If this story of ancient innovation has changed the way you look at the potential of natural materials, please subscribe and like the channel. We are dedicated to unearthing the history and technology that they tried to bury. Let's build a more sustainable future together. Our next exploration into forgotten treasures will be arriving soon.